Hi everyone, my name's Adam. In this problem, we're going to be starting with the given information that for the country of Paraguay, in the year 2015 has population 6.8 million, and the expected annual rate of growth is K equal to 0.012. And what we're going to be trying to find is the answers to these three questions. Part A, we're going to find the formula for the exponential growth and decay model, P equal to C times e to the kt, where we're taking specifically t equal to 5 is equal to the year 2015. And then we're going to find B, where we're going to predict the population using the model in A in the year 2030. And lastly, C, we're going to discuss the relationship between the sign of K and the population. So let's get started with part A. So for our model, which we have as P equal to C times e to the kt, we'll start by plugging in what we can. So this is equal to C times e to the k, e to the 0.012 times t. So what we need to find is the value of C. And what do we know? Well, we know that when t is equal to 5, that corresponds to the year 2015, which we know the population as being 6.8. So that implies that the population value when t is equal to 5, or P of 5, which is equal to C times e to the 0.012 times 5, is equal to 6.8. So this equation we can solve for C by dividing through both sides by the term e to the 0.012 times 5, where we get C is equal to 6.8 divided by e to the 0.012 times 5, which is approximately equal to, so 6.8 divided by e to the 0.012 times 5, and that gives us approximately 6.4 or 6.40. So in the end, our model is P equal to C, which we'll take as 6.40 times e to the 0.012 t. And we're going to be using this in part B. So go ahead and make sure that's nice and visible. Okay, so there's our model. Now in B, what are we trying to do? We want to predict the population in year 2030. Again, starting with what we know, we're told that t equal to 5 corresponds to the year 2015. And what we want to do is find the population in the year 2030. So what value of t would we have? Well, if we add 15 to get from 2015 to 2030, we're going to add 15 to our value of t. So 15 plus 5 gives us that t is equal to 20. So wanting to know the population in 2030 is equivalent to just plugging in the value of t equal to 20 into our model. So P of 20 is equal to what we have, 6.40 times e to the 0.012 times 20. And see, what is that equal to? So 6.4 times e raised to the 0.012 times 20 power gives us approximately 8.14, or 8.14, remember our units here are in millions. So 8.14 million. Okay. Now lastly, we're going to take a look at C. And what is C? We want to discuss the relationship between the sign of K and the population. So, well, for starters, K, which is positive 0.012, so the sign of it, positive or negative, it's a positive number. Now, what does that have to do with the population? Well, going back to what we know about our growth and decay models, starting back at the beginning, we have P is equal to C times e to the kt. And what we know about these models is if our rate of growth, or the value of k, is positive, then the value of p, or whatever on the left side, is growing or increasing. If it was negative, it would be decaying or decreasing. So simply put, since our k is positive, then we know our population say P is what we just say, growing, or equivalently, we can say it's increasing. And there we have it. Thank you very much.